Hello, I'm Eric Snodgrass, and thank you for watching today's in-depth ag forecast brought to you by Nutrien Ag Solutions. Well, over the weekend, I received several emails and a lot of text messages from growers asking me questions about the solar cycle and its potential impact on two things. Really, it was a question about this upcoming summer temperature and precipitation pattern, primarily in the Midwest. Most of the folks asking me about it were in the Midwest. And I also got asked about its relationship with La Niña. So questions came in. Let's get them answered here. So you've been looking here at a great website from NASA, the Solar Dynamics Observatory. And what I want to do is take you down here and show you what the sunspots look like. Now, this is just a live view of the sunspots, and so you can see a couple of them here, here, and here. And what we do is we monitor the number of these sunspots over time, and there's been a very well understood and well established cycle to the sunspots. So we're currently beginning our 25th sunspot cycle, and if you just look back to the mid-2000s, you can see they're actually in a very regular 11-year cycle. I can go back farther than that, now you can start to see it. So some of the questions come up is, does this have any sort of primary relationship with our temperature and precipitation patterns that we can use as a forecasting metric? Now, you probably noticed that over time, I don't ever really talk about the solar cycle and its progression, primarily because some of the work that I've done to study it and some of the peer-reviewed literature would suggest that it's not even not a primary, a secondary, or even really a tertiary piece of information or part of the overall what do I want to say here? Part of the overall control over the pattern. I would put it pretty far down on the list, and I'd just like to show you why. So since the folks were asking me about from the primary corn and soybean belt, I did a couple of things just to show you something. Now this is kind of an ugly graph, but you see here in the red, that's the 11-year solar cycle going back to 1895. What you then have here in this kind of gray would be the June, July, August temperature anomalies. So what we're looking for here is correlation. I then put an 11-year running mean on the data since there's an 11-year cycle in the sunspots. And essentially when you look at it and find the correlation coefficient, it's very small. In order to be a predictor, we need this to be above like 0.3 or minus 0.3, even, or much actually higher than that. Ideally like 0.6, 0.7, 0.8. That would be fantastic, which means that this correlation coefficient between these two data sets, and yes, I've done a lag study on this, I've looked at a lot of different ways, it's too low to use as a primary predictor, even a secondary predictor for the upcoming summer. So what we know right now is that we're going back into where we're seeing increased solar sunspots, So we're going back toward a peak of a sunspot cycle. And so I'm just sharing with you that I can't use that as any sort of a metric to forecast summer temperatures, especially in the Midwest. And when it comes to precipitation, the correlation coefficient's almost zero. So that's why I don't use it. And we have other evidence of this. You can look at my research, or you can look here at NOAA. If I try to correlate precipitation June, July, August against the solar cycle, what you end up getting is a map that looks something like this. And what you'll notice is that for most places around the country, the correlation coefficients are just too small to use. Now, no, I don't know what's going on around Evansville, and I haven't taken time to see what the correlation is in the Northeast, because you can see they're actually getting, here or maybe just on this side. But these correlation coefficients are small, and that's why I don't use it. Now, I got questions about this in La Niña as well, and I'm just going to show you. This is probably the most cited paper about the correlation between the solar cycle and La Niña. And I just want to bring you down here to the abstract and show you what they wrote. They of course provide evidence. This is a peer-reviewed paper in the Journal of Atmospheric Sciences. That is a prestigious and fantastic journal. But it does say there is, so far, no solar peak La Niña connection found that's statistically significant. So that's why I don't use it. I just thought I would offer up an explanation of that. But let's talk about La Niña, because we are now in the second just past the second peak of our current kind of La Niña phase. We had a big one that was last winter, one that was this winter, and we noticed, and I've talked about this a lot, La Niñas are often double dippers. They tend to come like this, but they naturally fade towards summer. And that's why the correlation, even between La Niña and summer weather patterns, is generally low. At best, it's like 0.3. So we're not talking about things that are statistically highly correlated, even though we use La Niña as one of our dominant predictors for summer. So I would just like to point that out. And we've been discussing how there's evidence of having yet a third La Niña, which would likely develop later in the fall and next winter. So thinking about all of that, this has still been the thing that I've had a lot of concern over. We have maintained a negative PDO signal. We have seen this La Nina continue to strengthen throughout this spring when we had suggested that it would continue to fade. So it's maintained its strength and cooler water has shown up back here. So let's do something with this and start to analyze it. First, it's not going anywhere. See this? Over the next 15 days, strong trades are still here coming across the ocean, right in this area, toward Indonesia. Then we have coming out of the Indian Ocean, westerly wind component. They're going to meet somewhere. It's going to be right here. And they've done this time and time again. Our Southern Oscillation Index right now, again, it's a comparison of the pressure in Tahiti and Darwin, Tahiti in the Pacific, Darwin in Northern Australia. This is just telling us what those trade winds are doing. It's a metric to measure them. I've told you before, you got to have a value above 7. We're sitting up here at a value of 20. And if you just look at this, we would expect it to continue to stay in that position. Now, if it is maintained and those cooler waters, stay something like this going forward, why do we have concern about summer drought? I want to make this very clear. Predicting this is not an exact science. We are speculating here. We're actually just using one variable to base this upon. But there's history behind it. Because when we look out there and see some of our models, like the CFSV2, maintaining through April, into July, even out to October, even look at the envelope of the ensemble members. You need to get above this, you need to get above this line for there to even be a hint at El Nino. We're just keeping those ocean temperatures cool out there in the middle of the Pacific Ocean. So we know a thing or two about that. Let's shrink this up so you can see it. There we are. Since I got asked those questions by some Midwest farmers, I looked at June, July, and August for some pretty heavy hitter years for drought, like 2012, 88, 76. You can read on down the list. What you notice is that there tends to be cooler water here and here, and also that negative PDO signal that takes over from the Gulf of Alaska all the way back toward Japan. Now, in those particular years, we tended to, in the middle of summer, produce troughs in the Gulf of Alaska, which meant the jet stream bounced up like this into a ridge over the Midwest. That's a good blocker of Gulf of Mexico moisture, and we just tend to get hotter and drier in the midsection of the country. So that's why we just continue to look at these ocean temperatures, because when that occurs, you tend to get a signal for low precipitation rates and drier conditions. And that sits right on top of basically the Western Cornbelt. That's why we have the elevated concern this year. No, I'm not making a slam dunk prediction on this. I'm explaining to you why these long-range models continue to produce what they produce, and we'll visit them again in just a second. On the flip side of that, how about June through August for those really wet years in the Midwest? See them all listed down here? We had ridging in the Gulf of Alaska. The flow came around, dipped into troughs, cooler weather, more inclement weather, and in some of these years, very, very big yields. And that's because when that occurs, the ocean temperatures tend to go warm here. We don't have a strong ENSO signal. And what it does is it takes the drought risk and pushes it west. So putting that all together, we are here. And what we're watching is, does this area stay warm south of that line? And do we go colder or stay colder here? That's our only preseason signal. You say, what about the Atlantic Ocean? Does it have a signal? It does have a signal. Let's go back and show it to you. Cooler water here versus warm in the Gulf Stream compared to average is a signal for issues with drought in the midsection of the country. We don't have that full signal just yet, but I could make an argument that the signal is stronger in the Pacific upstream than it would be in the Atlantic, which would be downstream for the jet stream pattern. Sorry about that. So we come back to this. The latest updates we've gotten from NOAA, from the European model, which, by the way, the European model updates on the 5th, so I'll be giving you that new information soon, is that there's elevated risk of drought here. That's all that we're saying. That could also mean an active hurricane season. No, we're not calling for record, but it's just an indicator that we could have an above-average hurricane season and an above-average southwest monsoon. These are the things that these long-range forecasts are based upon, and that's why they look this way. That's all I want to explain today. That was the main conclusion behind all of this. Now, I'm going to make a caveat to this entire thing. I think that this next month, the evolution of the ocean temperatures is critical, but also we need to see where the heat sets up early. The farther to the west it sets up, the more likely the ridge will be west, and we could get northwest flow through the Cornbelt where we've been talking about, and better thunderstorms. But as we stated earlier in the month, last month, if the ridge is here versus here, that just expands the drought risk east from the plains if the ridge is setting here or setting up there. So let's just keep that in mind as we do some of the new analysis that'll be coming forward. Now, certainly over the last 7 days, we have done a lot to really help out with this drought. Now, there's been a ton of severe weather in the plains, including that incredible tornado in Andover, Kansas. If you haven't seen it yet, it was amazing to watch and devastating to see. But look at the rain that's fallen here. Look at the flooding we're continuing to have here on the Red River Valley of the North. Some of this rain, though, and yes, these severe storms have hammered regions that have been in drought. And here's a good way to look at this. A week ago, a little more than a week ago, on the 25th, the extent of the drought region looks something like that. Here's what it looks like now. So soil moisture down to 16 inches before and after. The flooding here, this is continuing to cause problems with spring wheat. This is going to cause problems with planting delays later. We're still flooding on the Red River Valley of the North. So these are the things that we are attempting to predict and see as they continue to evolve, because the month of April was near record wet or record wet here, and it's just been lately that we've eaten away at the drought in this area. We've had frequent weather events that have come through and kept us out of the field, including cold weather in the eastern Corn Belt and a lot of rain down here in the Mid-South. The Northwest, cold and very wet. All right, so before we do an assessment on where all of this is going, I want to remind you of something. The European model gave us this forecast for April, back at the end of March. This is what happened. This was the forecast. I gotta admit, the European model picked up on this pattern and sniffed it out early. And it continues to do a good job at finding this unblocked jet stream pattern across the Pacific Ocean. There is no shutting this down really from the Himalayas across Japan all the way over to the West Coast. So that's why when we look forward, the next 15 days continues to bring more precip in here into the Northwest. That's primarily over the next 7 to 8. And systems continue to kind of eject into the central part of the United States. Now I'm going to talk about some windows opening in the eastern Corn Belt, but we're going to continue to try to beat back some drought in this area. And NOAA saw this as soon as we did too. And what they did was they adjusted their new outlook for late spring, early summer. They released this on the 30th of April. Now you start to see that drought remains but improves in this area. Now what we have to ask is what happens after that fact. We need to remember that some of the longer term forecasts continue to suggest that going into summer, this is the risk. But in the near term, there is some possibility that we could work on this drought. What's helping it along is the MJO. Because of those strong trade winds, there's the chance the MJO pops out into phase 4 or even phase 5. Does it make it into the Pacific? I don't think so. But if it pops out here temporarily, take a look. That's a southeast ridge. That's active flowing through the middle there and more troughs coming into the northwest. That's why our next 15 days look the way they do. What happens after that? If the MJO collapses again, which I think it is likely that it will do that, and it will not make it into the Pacific Ocean, then I buy into this. This is the May 15 to June 15 outlook from the European model, brand new, just released about 30 minutes ago. And what has it done? It's given us that same look that we worry about when the MJO collapses and there's a La Niña. Drier west of that line. Active everywhere east of it. I know you're like, but I see drier in here. Well, I still think we're going to see above average precipitation everywhere east of this line going forward. But this is this is brand new data this afternoon, European model, which I just showed you was a good performer for the month of April. So this is May 15 to June 15. This is a signal I've got to watch carefully. It's consistent with some of the things happening in the Pacific Ocean. Yeah, in the near term, we could get some relief, but we need to see how long it is sustained. Because it's not just the European model seeing this. This is the CFSV2 week 3, week 4 forecast for, as you see here, the middle to third week of, or the middle of May to the 22nd, and then the end of May. Notice that it has a drier signal there as well. So I'm going to watch it carefully. If it changes, it changes. But we need to know if that's going to be a possibility. And I'm just saying that right now it is physically consistent. So let's monitor it together. Okay, now what's going on right now is this. Been watching some satellite imagery today. Look at this next system coming out here. Look at the smoke from the fires in New Mexico, and then watch the storms blow up right here on the dry line. These are some big storms producing hail, starting to rotate. We're just now watching this afternoon, so we're going to need to keep a close eye on this. Storm Prediction Center has been all over the severe weather. In fact, they got to watch out for it right here. But there is some cold air on the backside. All of this in through here, this is a freeze warning on the backside of this. Got some cold conditions on the backside. But out ahead of it, this is where we have a moderate risk for severe storms today, and you've already seen the storms popping up there. By the time we get into tomorrow, that's Tuesday, we see that moving over to this part of the Ohio River Valley. All right. And then as we get into Wednesday, it's here again. The next system's coming out. I'll show it to you in just a few seconds. Even Thursday, according to our kind of severe weather index, we expect it to move into the Mid-South, into this area from, really Wednesday into Thursday. So we have 4 days of severe weather that are coming. Let's go into the high-res NAM to get a good look at this. So here's the first system today. The models did a good job with the initiation here. And you can see that storm system, there's some blue on the backside of that, some snow possible in Nebraska. That system then pulls right into Iowa, Illinois, Indiana. This is in the overnight hours tonight, leaving a frontal boundary stretched back all the way to just south of the Red River Valley here. Now going into the morning on Tuesday, Tuesday midday, Tuesday evening, see where the frontal boundary is? Scattered storms ahead of it in the Carolinas, but we're going to watch right in through here, all the way up into Ohio for the potential for some stronger storms on Tuesday evening. Now that system moves into New England, bringing in rain, but you see how it leaves a lingering front? That lingering front's going to link up with the next system, which just came through over here early Wednesday morning, and it comes out in the plains, and that's why we reset to bring the severe threat back into this area by Wednesday night. So that's system number 2. And oh, by the way, there's another one coming in over here, but we got to flip over to our multi-model analysis to see that. So these are today's new runs. We've already seen through this point. So there's Tuesday night, getting out into Wednesday morning, and let's watch the next system. Both models are pretty good on the timing of this Wednesday afternoon and evening. So again, this is where we're going to be watching on Wednesday for the severe storms. Notice how far back to the west they're getting though, hitting those drier areas. Let's play through Thursday. So this is now Thursday morning, Thursday midday, Thursday evening. You can see it is in both models here, and that's where we're going to watch this area for strong to severe storms on Thursday night. Going forward, that system moves slowly, and it's cut off from the upper level flow. There's a deeper trough coming into the northwest again, but this system here is going to move over the Carolinas and then sit and spin. Watch. This is Friday midday, Friday evening, Friday overnight, Saturday morning, Saturday afternoon, Saturday evening. So you see how it just sits there? The GFS is faster getting it out, but the European just leaves it lingering in this particular area. Now, the next deep trough that comes in has got a different trajectory. It's going to try to toss its systems farther to the north. So watch, going from Saturday into Sunday, just kind of move it quickly back and forth. See how the next system shows up more here with possibly some snow on the backside? The GFS is quicker, getting it all the way over to Manitoba, dragging a front through the middle part of the United States. The European's much slower with this low. So we got something to watch for next week. But what's important to me about this is a couple of things. Model differences. Wherever you see these colors, the European is wetter. These colors, the GFS is wetter. Take it from there and look at the WPC. Heavy rains forecast for this area and east. Let's now go look at the probability of getting at least an inch of rain over the next 10 days. Better than a 90% chance here. This is the chance of getting 2 inches of rain. And this is the chance of getting at least 4. That's a 50% chance of 4 inches of rain in the next 10 days. Very, very wet into that area. So when I come and look at all of it, I'm like, this could be the push that helps to hurt or beat back some of that drought into this area. But it's also going to soak a lot of places. Now, when does that end? Take a look at this. This is by May 10th. Now, remember I told you that second trough ejects farther to the north? Well, watch. Tuesday, Wednesday of next week has a hard time getting over this ridge. So what we end up getting out of this pattern going out fully into week 2 is windows are going to open in this area. The temperature's coming up. We're going to see planting windows from the Mid-South into the eastern Cornbelt, while all the action from that deeper trough ejects here. Problem is, We're going to continue the flooding on the Red River Valley of the North, continue the planting delays across the north, keeping it cooler across the north. Could get some better storms to the south, but this is a window that we do think is going to open. Now, to have that discussion, I got to talk to you about temperatures because April was brutally cold. What are the temperatures doing? Our frost threat is shown in gray. Now do you see the windows opening we were talking about here? It's there in the temperatures, and let's see what those max temperatures do. So here's Monday. Already seen these. Tuesday, high temperatures compared to average. Wednesday and Thursday. So a lot of colder air in place through the middle and into this week. But here's what we're waiting for. Going into Friday, it starts to shift east. Saturday and Sunday, the temperature pattern starts to open up as the new deep trough comes in the west. So what you're going to notice is this. If I give you kind of a 5-day sliding window, there's the cooler weather the next 5 days, but watch. Going into the weekend, starting next week, this is next week now, out May 11th, 12th, 13th, see the deeper trough digging into the west? That is yet another blast of Arctic cold air there. And don't forget, that area has had its coldest April on record. Well, what we've got now is that by the time we get out there to mid-May, this is warming up, soil temperatures come up with it, and you saw the drier signals in the eastern Cornbelt. I think we're going to see a lot of folks pushing hard to get this crop going at that point. So that's what I've got for the next 15 days. How about a little international update with South America? February, March, and April, we saw drought develop east and then spread over to Mato Grosso. We're now starting to see some of the major analysts pull back the numbers on the Safrinha crop. Here we are in the month of May, and we see near normal precipitation in this area. But it's just a reminder, if I show you the total precipitation, watch, I'll go all the way out here, I don't know, let's go out 10 days or more. Just understand that where that Safrinha crop is growing, we're seeing these numbers down here in the 5 to 12 millimeter range. This is not much precipitation despite the models going wetter. That's because it's the end of the monsoon season and the start of the dry. So the Safrinha crop finished dry, and that's the main story I want to finish with today. I'll be analyzing all of this all week long. I'll report back to you again on Thursday if there are any changes, but I hope you found it informative and useful today. Okay, talk to you then. Thanks.